So the first method that you're going to have to do is solving by graphing. It can be in slope-intercept form or it can be in standard form. So this first one is in slope-intercept form. You can go straight to the graphing. You can start with the y-intercept, +4. The slope is -1, so down 1 over 1. And you're going to graph that first line. And then you're going to do the same thing with the second line. You're going to start at the y-intercept. In this case, the y-intercept is -4. So I'm going to start at -4. The slope is +7, so up 7 and over 1. And you can see that actually falls exactly where I placed my other point. And so once you've graphed it, you've done the work behind it, but you still need to list your answer. Your answer is going to be where these two cross. All right? And so you want to make sure that you are giving me the answer for where they actually cross. And so you look on the coordinate plane, they cross at 1, 3. So your answer here is going to be 1, 3. All right, that's slope-intercept form. If it's not in slope-intercept form, you can put it in slope-intercept form. So if you look at the next page, those are in standard. So if I want to change these to slope-intercept form, I can do that. You can graph with your intercepts. But I will say that if you do it that way, you can't really walk the graph like you do when you have a slope. And so I typically put them in slope-intercept form if I'm trying to walk to the exact point. So in slope-intercept form, I would move my x over, and then I would divide everything by that -1. So if you move your x over, it looks like this. And then if you divide by -1, you have y equals x plus 8. On that second one, I'm going to move my 2x over. And then I'm going to divide by that 3. So y equals -2/3 x minus 2. So I have those two. All right. And then I'm going to graph them. So the first one I start at 8. And I'm going to go a slope of 1. All right. So a slope of 1 is just up 1 over 1. And you can do multiple points if you want to. I would recommend using a straight edge when you connect your dots, just because you are trying to solve by graphing. It gets you as accurate as possible. The next one, I'm going to start at -2, and I'm going to go -2/3. Now, normally I would go down 2 and right 3, but I know that my line is up and to the left, so I'm actually going to walk it. I'm going to go up 2 and left 3, right? And so that puts me right here, right? Up 2, left 3. And I'm going to walk it again, up 2 more and left 1, 2, 3 more. And you can see exactly where you cross if you keep walking with your slope. And so then I can see exactly where those are going to cross. They're going to cross at that point right there. And again, once you've graphed it, you need to actually list your answer. The answer is right here at -6, 2. So my answer to this one is -6, 2. All right. So there are 3 basic things that can happen with substitution. The first one is they could have one variable already solved for you, and you can go straight to the substitution. Sometimes both of them are solved for a variable like this, and you can set these two guys equal to each other. And then sometimes none of the variables are solved, and you have to solve a variable before you start, okay? And so if it's like number 9, it's ready to go straight to substitution. I already have y all by itself, so I can take this group and plug it in for the y in the first group. So I can say 5x plus 2, and instead of y, I'm going to plug that in for y. And then equals 23. And then I'm just doing a basic solving equation. I'm going to distribute. I have 5x minus 10x plus 38 equals 23. Combine my like terms here. So 5 and -10 give me a negative 5x plus 38 equals 23. Subtract my 38. I get negative 5x equals negative 15. And then when I divide by negative 5, x equals 3. So I already know that x equals 3. I need to solve for my y. Y equals negative 5 times x plus 19. Y equals negative 15 plus 19. So y is going to equal 4. And so I now know my y value. All right. You have both of these solved for the same variable. You can just set each of these groups equal to each other. You're basically replacing that with a group. So you can say, well, 4x plus 1 equals negative 6x minus 19. Just set the two groups equal to each other because they're both solved for the same variable. And then you can just get all your variables to one side. Get all your numbers to the other side. And then solve for your x there. And just like the other one, plug it into either equation to solve for your y. I know my x value. I need my y value. Y equals 4 times x plus 1. So y equals negative 8 plus 1, or negative 7. So now I know my y value. And I am done. Always solve for x and y. And then the third one, you really don't have any variable solved, so I am going to look for the easiest one to solve. And when I look at this, if it has a coefficient, it's probably not the easiest one to solve. And so I'm going to look for one that has a 1, like this x right here. So I'm going to choose to get this x by itself, meaning I'm going to move that negative 8y over. So x is going to equal positive 8y plus 9, right? Because when I move it over, I change the sign. And now that I have set it by itself, it looks just like number 9. I'm going to take whatever's there and I'm going to plug it into the other equation. And it'll be the same process. I'll just plug it in. Negative 3 times x plus 4y equals 13. And I will solve. Distribute. Solve for y. When you get y, plug it back in. So this looks just like 9 once you get one of the variables by itself. So once you get a variable by itself, you're basically doing the same exact thing that you did before. Combine your like terms, move it over, solve. All right, and so you can have any of the above really. So just make sure you take your time with your so that you can not miss those positives and negatives. I will say, once you have your x and your y answer, you can plug it back into those equations and it should be a true statement. So for any of these, you can say, well, 3 and 4, 5 times 3 plus 2 times 4 equals 23. Is that true? You know, and so you can go back and plug those in and check and make sure that you got the right answer. So the first type of equation is, it's really set up for you. You're going to look at it and you're going to say positive 10 and negative 10. That cancels x out. Done. I can just go ahead and just go straight to the elimination piece. And so if it looks like number 21, I'm going to go straight to the addition part of this. And I'm going to go ahead and add them. 10 and negative 10 cancel. 7 and negative 5 give me a 2y. Negative 9 and negative 5 give me a negative 14. I divide both sides by 2. Y equals negative 7. So I know the y value I need to find the x. So I'm just going to plug that in. Negative 10x minus 5 times negative 7 equals negative 5. So I have negative 10x plus 35 equals negative 5. Subtract that over. Negative 10x equals negative 40. Divide by negative 10, x equals 4. So I have my x and y. All right, so when it's already set up like that with one positive and one negative, it's pretty simple. Go straight to the addition piece of it, and you are ready to go. There may be times when you have to multiply one of your equations to eliminate a variable, and I'm always going to pick the easiest one here, right? So in my opinion, I would eliminate the x because I would have smaller numbers versus a y where I'm going to have to multiply something like 30 by 6, right? And so if I see automatically that I have multiples, then I'm going to say, well, I have a negative 9. If this were a positive 9, it would cancel. Well, how do I make negative 3 positive 9? Well, I multiply by negative 3. And so I can multiply this entire equation by negative 3. And I will get a positive 9x, a negative 18y, so 60 and 21. Now I have two that I can add up. I will say either rewrite it or kind of draw a line through this so it doesn't confuse you, right? I mean, make sure that you're not, if it's the one below it, either rewrite both of them or just cross through that middle one so you know to add the top and the bottom. So I have negative 9 and positive 9, those cancel. I have 1y and negative 18y, that's negative 17y. And then I have positive 30 and negative 81, that is negative 51. That is divisible, so divide both sides by negative 17. That is 3. And just like everything else, once I have one variable, right, I have the y value here, solve for the other one using any of the equations. So if I have negative 3x plus 6 times 3 equals 27, negative 3x plus 18 equals 27, subtract over, negative 3x equals 9, so x equals negative 3. And so I have my x value there as well, and I am done. All right, you may have occasions where you have to multiply both of them, right? And again, I'm going to pick the one that's going to give me the smallest numbers, okay? And so if I'm looking at these, between 8 and 9, my common factor, least common multiple is a pretty large number, right? So I'm going to move on to the y, and I'm going to do between 4 and 3, right? And I already have a negative and a positive here. So I'm going to make both of these 12. So I'm going to multiply this group by 3, and I'm going to multiply this group by 4. This is just like the bell work here. And so 3 times negative 8, 3 times negative 4, and 3 times negative 28. All right. Then I'm going to do the 4. 4 times negative 9. 4 times 3, and 4 times 6. So now I have a positive and a negative, and it's going to cancel. So 24 and 36, they're both negative, so that gives me a negative 60. X, negative 12 and positive 12 cancel. Negative 84 and positive 24 also give me a negative 60. So my x is going to equal 1 when I divide. So I already have an x value. And again, just like everything else, plug it back into one of those. 8 times 1 minus 4 times y equals negative 28. Negative 8 minus 4y equals negative 28. Add it over. And so I have negative 4y equals negative 20, divide y equals 5. And I have my y value, x and y, and I am done.